Welcome to ASCII Geek.
Hey, if we haven't met already, I'm the digital avatar of ASCII Geek,
where we build your next advantage with tomorrow's technology. And today, one of our experts is stepping in to show our latest breakthrough. Enjoy and happy learning.
All right. An enterprise data pipeline is built for continuous flow, but scale that pipeline to handle generative AI, and eventually the entire system stops. The logs grow a 429 error, too many requests. It is a throttling mechanism, indicating you have hit your API rate limit. But a review of the metrics shows the system is actually operating well below its assigned token limits. This diagram compares standard web services to large language models. With traditional REST APIs, throughput is determined by the payload actively moving through the gate. Send a small payload, and it clears quickly. Send a similarly sized LLM payload, and the system blocks it. LLM APIs do not meter traffic based on what you transmit. They govern access using highly predictive quota reservation algorithms that trigger before the model even begins processing your prompt. Compounding this is a dynamic token accounting system. This actively decouples the hard limits of your input from the actual computational constraints of the provider. Controlling costs and eliminating throttling on models like Claude 4.6 requires mastering two specific architectural mechanics: upfront token reservation and the cache-aware rate limit bypass. Maintaining API stability means abandoning the instinct to optimize the size of the payload. The bottleneck is the underlying token reservation logic. To map exactly how token quota is consumed at the infrastructure level, we can look at the architecture of Amazon Bedrock. Bedrock calculates token consumption in 3 stages: request start, processing, and request end. The bottleneck occurs right at the beginning. At request start, the system instantly claims a massive block of reserved quota. The API does not measure the actual length of your prompt here. It calculates this initial reservation blindly, basing it almost entirely on the max tokens parameter defined in your API call. If you leave that parameter empty, the system defaults to the model's absolute maximum output capacity. For Claude Sonnet, that default is 64,000 tokens. Look at the math. You send a 1,000 token prompt. With max tokens at default, the API instantly reserves 65,000 tokens. During processing, Bedrock shrinks the reservation down to the true 100 token output footprint. But initially, 63,900 tokens were unnecessarily locked up. Fire off multiple concurrent requests under these defaults, and those phantom reservations stack. The system rejects incoming API calls because it mathematically calculates it is operating at absolute capacity, even when the actual compute load is negligible. Unoptimized token reservation is the specific architectural flaw that allows light workloads to crash an entire system with severe 429 throttling errors. While Bedrock exposes the danger of structural reservation, Anthropic's own Claude API utilizes a decoupled architecture that allows you to bypass strict limits. Claude separates its rate limits into requests per minute, output tokens per minute, and input tokens per minute. For Claude 4.5 and 4.6, tokens read from the cache bypass the input tokens per minute limit bucket completely. If a system maintains an 80, this chart shows Anthropic's long context premium. The moment a request surpasses 200,000 input tokens on Claude 4.6, the baseline cost of every input token effectively doubles, but setting a cache on repeated context drops that cost by 90. Rule 2. Heavily cache system prompts and large context data to multiply your organizational throughput. Rule 3. Isolate inputs exceeding 200,000 tokens and fast mode workloads to explicit routing paths. This prevents premium multipliers from spiking the bill, pushing non-urgent data into the discounted batch queue. Purchasing higher organizational usage tiers rarely solves structural throttling issues if the application continues to mismanage token reservation. Throughput stability and cost control are highly elastic variables dictated by architectural discipline.
That's the update from the lab for today. I hope you learned something new. Head over to ASCIIgeek.com